Anybody have any other questions? If not, I'm going to turn it over to Jerry.
Thanks. Well, if I haven't met everybody, I'm Jeremy Druin, an education officer for this chapter and lead pen tester for a local company. And today I wanted to take a look at SQL Server as an example of database pen testing and also remediation. I'm going to use SQL Server as the example, but try to keep the concepts definitely high level, especially when we talk about remediation. I'm going to try to keep that at a higher level because all of the concepts are applicable to Oracle as well. And we've tested all of these on Oracle systems, and they work fine. But the terminology is different, and exactly which buttons you click on and stuff like that, of course, is going to vary widely between the two systems. So, not picking on SQL Server, it just makes for a great example, and I could get it running on Windows pretty quick. All right. So, not going to have any slides today, but it's going to be more of a workshop style. We do these workshops each month that we have a regular meeting, and we do it at 1 o'clock afterwards. So today is going to be in this workshop style that we do. If you like this hands-on demo-based type of presentation, we do one every month after the regular meeting, and you're welcome to attend those as well. We are going to have a workshop today. I've noted some items in the list we're going to look at that are going to be saved for the 1 o'clock workshop. Those are some of the more advanced topics that we're going to get into. So the first thing to talk about is, how does SQL Server listen on the network, basically? Because if you're going to essentially break into one, or if you're going to audit one as an auditor, or if you're going to pen test one, the first thing you need to know is where are they, what ports do they listen on, how do you find them. So SQL Server has the concept of a server and an instance. The server can be more or less thought of as the physical host, or the operating system is hosting the SQL Server environment. And then you can spin up multiple copies of SQL Server on the same physical hardware, and they will run as independent processes. So you could have 3 SQL Server processes running, or 5, or whatever. Those individual processes are each bound to a particular network port that they're listening on. Of course, they have to be different ports. And each process can be thought of essentially as a different server. They're called instances, and they have names that you give them when you configure the instance. So the instance is the same thing as a process, and processes are listening on network ports. Now, a database is a virtual concept in SQL Server. The process running, the server running, can have multiple databases on it, and each database is independent of the others. Now, they're all running on the same instance, but other than that, they don't necessarily have to have anything in common with each other. You can develop one database for one department and another database for another department, and they can happily coexist side by side. Neither will even know the other one is there if the permissions are correct. So, I mentioned that instances run on network ports, and they have to be different ports. So you can run the first instance on the default port of 1433, or I've seen some of the newer versions run on 1031. But obviously the very next instance you spool up is not going to be able to be on the default port. You're going to have to pick some other number. It doesn't really matter what the number is. It can be a high port, but it needs to be different than default. Sometimes DBAs will spin up one instance and not have it on the default port. They'll spin up multiple instances and not have any of them on the default port. So trying to find SQL servers based on the default port can be hit and miss. Talk about where the remote connections are configured. So in the SQL Server Configuration Manager, which comes with SQL Server when you install it, there's a network configuration setting. This is where you pick like if TCP/IP is enabled in the pipes and so forth. And in the configuration manager, you can set up different ports. There's also the SQL Server Management Studio, which is the client software that Microsoft has to connect to your SQL servers, and you can configure them using the SSMS tool as well. So in this case, we'll connect to this server. So we can see the server name is basically the computer name on the left, and then slash, and then SQL Express is the instance's name. And since this is obviously the SQL Express version of SQL Server, you can only have one instance. If you want to have multiple instances, you buy the paid version. Okay. Well, if the ports are determined by the DBA, and to some extent they're going to be relatively random, because the DBA is going to just choose them based on the convention that they use. How do you find SQL servers on the network? Well, there's a browser service running that's separate from the databases. And that browser service's main job is to listen on the network for someone to ask it which ports are the SQL servers running on. So if we take a look at this SQL server, let me back up a little bit, actually go back to Windows. You can see that the SQL Server service, the process is running, so that's essentially the database server. But there's also a second service called the SQL Server Browser Service. So this process is listening on UDP 1434, and if it hears a client send the question of what databases do you have, it'll return back a list of all the databases on the server. So that's how we're going to find the SQL servers, and that's also how we know which ports they're running on. So for configuration, you have services.msc, the regular services program, and then you can also use the SQL Server Connection Manager we just looked at. Okay, there are ways to detect SQL servers passively. Might not be obvious at first, but if you think about it, if you look in the DNS entries of most companies, they give the computer names something that indicates their purpose. It might be a web server, typically those are called www or whatever, right? And then you might have something called, MSSQL 12 or something. Well, that's probably an SQL server. So if you just get a listing of the DNS host names, possibly through a zone transfer or something like that, and then look through the list, you may just find the servers. The remediation for that is pretty easy. Just don't name your computers anything that indicates their purpose. Give them some kind of a random name or a mnemonic that indicates where they are in the data center or whatever, but doesn't mean anything to anybody on the outside. Now, as far as detecting them using scanning, we'll do that now. We'll use a few tools. The first one, the one I tend to use the most, is Nmap. Nmap's interesting in that let's scan that host. Let's scan 100 through 105. We actually have the SQL server running on 101, and we'll go ahead and say identify services. So we use the -sb flag. So Nmap is a tool that will go out on the network, detects hosts, and then it detects the ports that are running on those hosts that it finds. And then for each port in turn, it'll try to determine the service or the process that's running on that port. To do the service detection, that's the -sb flag, or if you send in -A, which means detect services and do a whole bunch of other stuff too, it'll try to figure out what's running on each of those individual ports. This is going over a slow virtual network, so it might take just a minute for it to complete. Oh, sorry, Adrian?
Okay. You mentioned scanning for host names. Besides zone transfers, which depends on where you go, sometimes a lot of times they're turned off anymore. You can also do Nmap space dash lowercase s, uppercase L for list scan,
Mhm.
and the IP address range, and it'll do a reverse DNS lookup on every single one of them. And that's a
Yes.
great way to find out what different boxes they have out there and what things they're running.
Yes, and that, even though you are using a scanning tool, technically that is still passive because you're not actually querying the servers directly. You're hitting the
They'll
DNS
see a bunch
servers.
of DNS traffic from some other DNS server,
Right.
my understanding, but not necessarily you.
That's true. So that is passive. That's a great trick question for a test, anyways, whether that's passive or not. Also, along that same line, that you might use an online web service like Robtex or Domain Dossier or one of those services that already have DNS records for companies hosted at their website. So it's still passive because you're querying a service other than the target. Okay, so we found a service running on port 1031 TCP, and Nmap just took a guess at what it is. It didn't indicate it's a SQL server. So let's try a little bit different scan with Nmap. Instead of saying search just on TCP, we'll send in a -S capital U, which is UDP scan. And then we'll say, let's look on port 1434. That's the port that the browser service is listening on. And then let's go ahead and try to identify the services with the -SV flag. Excuse me, I'm going to change that from 100 through 105 to just 101. Speed things up because in the prior scan, we already noted that the IP address is at 101, so we don't need to do the range anymore.
Jimmy?
Yes.
Is the service customizable? I know for the SQL server service it is. but for the browser
Customizable.
Like you can, instead of using port 1434, you can
Oh.
customize it for like another high port.
Mhm. No, you can't because the clients are hard-coded to look on 1434. So if you did change the port somehow or force the port to change through some kind of, say you used a firewall to reroute it or something like that, your clients are going to fail.
Sure.
So changing the port would be effectively the same thing as just turning it off.
Okay.
All right, so this time when port 1434 was scanned, notice that the service detected was MS SQL instead of I-82. And additionally, Nmap is smart enough to where it said, hey, I know what that is. It's an SQL Server browser service, and let me just go ahead and get the information for you. So it figured out the server name, and notice that over here, what we were looking for, the TCP port 1031, that the SQL Server process is listening on.
Was that first scan, was that just doing well-known ports, or was it doing full-on everything?
When you run Nmap default, it scans TCP only, and it scans the top 1,000 ports, most common ports. Good question. So now that we know that it's TCP port 1031 and its IP address 101, we would record that information. So this is a good way, if you're an auditor or a DJ perhaps, of a very simple way to just quickly browse your network looking for rogue SQL servers. The tool's free, it's easy, and it's fast, and it gives a great report in the XML format that you can look at in a regular web browser.
Jeremy, for remediation on that, if you wanted to hide your SQL servers, could you turn off the browser
Yes.
service?
Yes, what you would do is you would basically you would just disable that service. When you do that, you need to tell your clients in advance how to connect. So what we would do is we would say, like, let's say the server's name was not feeling very creative today, called server. So we would type server, acme.com or whatever, and then we would say the instance name, which in our case I think it was like SQL Express or something like that, and then we need a comma, and then we would say 1031. So you would send that information to your clients, and you would say, when you're indicating your server, type, cut and paste this in. And that comma took me like 2 hours to figure out. So I remember one time we had firewall rules that blocked and I had to try to get connections set up, and I was like, I have no idea how to save the port, and you can't find it online very easily. So,
Jeremy, when you're connecting from outside our network, we have to use that common port. I guess the browser must be out of the picture.
yeah, the firewall blocks UDP traffic,
Right.
so you can still send the UDP request, but it gets dropped and the service never hears you. And I think the SQL Server service responds in UDP as well, so it would block it on the egress as well. So that'd be kind of a double whammy. All right, let's look at some other tools that can find SQL servers. I have a preference for Nmap because in addition to trying to find the SQL servers, I can run it and do 50 other jobs at the exact same time for other stuff I'm looking for. But there are dedicated tools that just look for SQL servers that might be helpful depending on your situation, especially if you're an auditor or an EBA. Okay. So one of them is inside of Metasploit. I've already started up MSF console, and we're using auxiliary scanner, MS-SQL, and the MS-SQL ping tool. Can't remember that, don't worry about it. Just when you're in the new version of Metasploit, just say search MS-SQL, and it'll pull up all the tools related to SQL Server. And somewhere in this big list, here it is MS-SQL ping, and it says MS-SQL ping utility. As far as I know, it's pretty safe to use. I've used it lots and lots of times and never had any problem. I guess that's not very scientific evidence, but anecdotally.
You never had the network guys come lynch you because you ate up all the bandwidth.
Well, on the laptop I'm using, I don't think the network people notice me. I've got slow machines. So. All right, so the options for this, we hit show options, and the options are password, which is not required, and then the host. Notice there's an S on the end, because a lot of the, if you're used to Metasploit, a lot of the tools are our host without the S. You can have a username and a password if you want, but you don't really need it. And the threads. So we're just going to keep this pretty simple. I'm going to use setg instead of set. Setg keeps it's global. It means that next time we run another tool, it'll already our host will already be set for us. We won't have to set it again. Okay, so we run it. It's very quick, and it comes back with the same information that we had gotten from Nmap, although it's formatted a little bit differently. It also gives us the named pipe over which it can connect. So, one of the things I like about the MS-SQL ping, and I do use it a lot after Nmap has detected the SQL servers, I'll go back with MS-SQL ping and do a sweep with the IP addresses that I get from Nmap. The reason is it gives the version in this nice format that I can put on a report pretty easily. So right here it says version 10, so that's 2008, 9 is 2005, 8 is 2000. I presume 2012 is going to be called version 11, I guess.
It is.
Okay. I haven't spooled one of those up yet, but it makes sense. All right, and another tool that we can use, go back to the desktop, is SQL Scan. This tool's for Windows. So I'm running it on Wine because I'm using Linux. Or I guess you could just go back and you could have a Windows virtual machine running as well. The nice thing about this tool, besides that it runs on Windows natively, is that it's fast. But it is pretty old. Still works though. Run, done. 10 hosts just like that. You notice it was a little bit faster than Nmap. Alright, so that's SQL Scan. And that's from Foundstone, which I think was bought by McAfee or somebody. Somebody got it, but the tool's still out there.
Now, do you know what that's doing behind the scenes? Is that using the browser service? Or?
Yes, they're all using the browser service, and in the workshop, starting at 1, we'll talk about how it works. So I'm going to save that topic. So, and then we already talked about remediation. Carl had asked earlier about how to remediate. All right, so browsing SQL Server, once we find them, well, I probably got this kind of in the wrong order because probably the first thing we're really going to need is a password. And in order to get passwords, it's not as hard as you would think it is, especially if you're already on the inside of the network. If you're on the outside of the network, obviously SQL injection is a good way to try to get some passwords. If you can pull off SQL injection, and if the web application is running with enough authority, you can actually grab the passwords from SQL Server itself. We'll look at that here in a minute. VB scripts, web applications especially, but really any applications, service accounts, Windows shares, developer workstations are all good places to find passwords to the SQL servers. DTS and DTSX files, those are data transformation services files. It's the files that run with SSIS, SQL Server Integration Studio, I think. And they contain passwords in like the third or fourth line down. They can be encrypted, but a lot of times for whatever reason, people don't do it. They just don't flip the switch to have the tool encrypt the passwords. If they're encrypted, they're salted and hashed, or salted and encrypted, not hashed. Very, very difficult to break. So for remediation, the actual remediation is pretty easy, but executing the remediation is not easy. So basically, in order to remediate, what you have to do is treat your development environment just like production. It has to be locked down, need to know access only, and obviously you don't want to just keep a file of passwords laying around. The problem is a lot of companies treat their development environments like development, and they just assume it's always safe and no one cares about it, and trust everybody inside the company because if they work here, they're not possibly going to do anything bad.
And also have a tendency to copy production data into the development environment.
Yeah, copy production and development, copy development and more development. You'll make a copy of the copy, right? So if you have reasonable controls around the development environment and treat it with the same respect you would give the production environment, chances are you can limit the kind of access that you would need to get into the files to open them up to read the source code of the applications and the scripts and things like that, the service accounts. Yes.
I think subversion,
What's that?
code repositories,
Oh,
Another
subversion. Mm-hmm.
and then backup files. I guess people forget.
Yeah, subversion or PVCS is popular, I think.
People forget and put passwords in there.
Yeah.
And they compromise that and they get the own passwords.
Yeah, again, basically just any source code, really, whether it's in a repository or whether it's on the workstation or what have you. Okay, so we're going to assume at this point that we have the password, but we can also try to brute force them. So there's a tool in Metasploit, the MS SQL login tool, where you can try a file of passwords. You can generate a file of passwords with John the Ripper and have it just create take a word list and mangle it, adding numbers onto the end and spelling it backwards and things like that to give you a better word list from your dictionary word list, and then run that against the SQL server. Also, the Hydra tool, THC Hydra, can take in a file and try them very quickly against an SQL server. SQL servers are pretty fast too, so you can check a lot of passwords really quickly. Yes.
Do they by default have any kind of lockout policy, or can you set a lockout policy?
By default, SQL Server 2008, I've noticed, has the boxes checked by default, and you have to uncheck them, so that's good. But it defers to Windows and Active Directory for the policy, so I'm not exactly sure on each individual server you're talking about if it's going to have the policy or not, since it's asking Windows for the policy, if that makes sense.
Okay.
So it's based on...
first.
I'm sorry?
If you use integrated security, which is recommended for a SQL server, it's going to use AD. So it's
Yes.
whatever policy you have in AD.
Yeah, it'll defer to AD
That's the
first
defense before you hit the server.
if you're a member of the domain.
Right.
And then it goes to Windows, a list of Windows local sources is secondary. It's exactly the same as Windows regular logins, right? I mean, it goes to AD first, and then it goes to the local account.
Yeah.
Because SQL Server just hooks into Windows and just asks its opinion of what to do. It doesn't.
I haven't looked at SQL Server in a long time. Can you still do purely local accounts, like purely local SA accounts?
Yes, those are called
Mixed
SQL
mode.
Server accounts. Actually,
Right.
is the name of them, or SQL Server logins.
They should be locked down.
They should be. Shoulda, woulda, coulda, right? So, so some things to try that have worked is set the username equal to the password, or try to mangle the username. Just try silly passwords like password, obviously, and try things like silly passwords with like a number on the end, like password 1, things like that, because it works. Remediation is basically the most obvious thing to do would be to increase your password policy. So you would have mandatory account lockout, mandatory character sets in your passwords, mandatory length controls on the passwords, which can all be set in Active Directory or in the Windows operating system. You don't have to set it on the individual SQL servers. You can integrate with Active Directory, mentioned that a second ago. And one of the things you can do also, especially if you have AD, is you can use smart cards, because Active Directory allows you to have two-factor authentication. So if you have a certificate story, you issue a certificate to the card and give that to the user. And then even if they do have a silly password, you still at least need to possess the card to get into the SQL server. So if you want to audit these, I'll just demo this. So it's a little easier to show than talk about. Oops. I think the rule of thumb on the remediation is don't let SQL Server manage the accounts. So, whatever you do. Which means don't have any of those local accounts. All right, so let me close this tool and go to SSMS.
Is there a way of identifying those that are just running off?
You have to set it.
Yeah, I'm going to do that now. Or I'm going to show you an example now of how to do that. So under management and then policy management and policies, I built this one yesterday. It's just a real simple policy that I put together just for demo purposes. Obviously, you can make it much more robust and have multiple checks. So what this one does is it checks a condition called the audit password policy enforcement. And what I did there is I basically said, give me a list of all of the logins on this SQL server that do not have the mandatory policy, the mandatory password policy from Windows enforced on them, if that makes sense. So in other words, mandatory password policy is equal to false. I want to see it. And I'm going to run that now. So I'm going to right click on it and say evaluate. And it goes through and it grinds through like you were asking a second ago. And then there's this one here, server. Let's make this a little bigger. Okay, password policy enforced is the flag I checked in my query, and the value is false. So the brokerage underscore QA account has violated policy and the audit has caught it. Just something for auditors and DBAs I thought might be of use to you.
So that's on that one particular instance, that particular server.
In this case, that policy is on that one particular instance.
If you wanted to do that across your entire environment, would it be difficult to?
I think probably, in my opinion, I think one of the easiest ways to do it would be to run the same type of query but use PowerShell, because SQL Server integrates with PowerShell really well, very, very good integration. And so I think it would be probably easiest, but opinions may vary on that. But that is one way to do it regardless, is use PowerShell. All right, so we covered locating passwords and guessing them and brute forcing them. So the remediation on that, we covered that, and I think now I'll cover getting into the actual server. So let's just assume that we've acquired a password at this point and we're able to get into the server. How do you look around for stuff? Probably the easiest way is It's just basically manually. And that's with this Management Studio. So if you go in here under databases and then pick the database, this particular server only has one database running on it. I should say instance, not server. You can click on tables and you can see all the different tables and stuff. So that's a pretty straightforward way to do it. Use, under programmability, would be the store procedures and user-defined functions, and also the system store procedures that you have access to. So you can look through the data that way. You can right-click on that and say select top 1,000 rows, and it'll pull up the top 1,000. It gives you the query here at the top, so you can go in there and change the query if you want. Let's see, you can script the table as in, say, like an insert, for example, and it'll kind of fill in the blank. It'll provide you like a fill in the blank deal. So we can do like one. Let's see, it's put in something just for fun. Okay, pen is 4. First name. Oops, round the quotes. By the way, SQL Server uses single quotes, not double quotes. Let's see, hopefully this will work. Oops.
Close out your bracket.
Yeah, brackets or something's not closed out here at the end, I think. Get to the end of this one, I probably deleted it. There we go.
There you go.
Yeah. Okay, so now if we go run the first query again, there's a record in there. Okay, so you kind of get the idea with the SSMS. Pretty much do anything in SSMS, more or less. All right, another way to look at SQL servers is using the osql command line tool. It provides most of the same features as the graphical tool, but it runs on the command line. You can still run queries. You can log in and have an interactive shell on the SQL server and all those fun features. We'll look at that later in the advanced workshop. Another way to browse is through SQL injection. If you get a SQL injection flaw in a web application or in a regular application for that matter, you can interact with the SQL server via those commands that you can pass through the injection. So the remediation, a little more complicated than the password issues, but it's not too bad. The first thing is you run all your applications with least privilege. They really only need one privilege other than the ability to log in, and that's execute. What you end up doing is you make a schema, or in Oracle terms, a package for the application. Put your store procedures or your user-defined functions inside, and you give the application rights to execute those routines that are inside of that package or schema. So when the web application eventually gets knocked over, the attacker is probably going to have that username and password that the application is using to log into the SQL server, or if they're using some kind of SQL injection, which probably won't work anyway with the routines, they would still only have rights just to execute the store procedures and the UDFs that are in that particular schema. Now in SQL Server, a little footnote, make sure that the schema is not DBO, because that's going to have all kinds of other stuff in it. Obviously you're not going to have any tables, views, or other private objects in the schema that the application is allowed to look at. Otherwise, if somebody breaks in, they're going to be able to have those privileges to look at those tables and views as well. Oracle makes this a little easier because in packages, I don't think you can even stick a table in there anyway. It's a little more straightforward. On the application account, obviously you would want to have as good of a password as you can put on it. Since it's an application, there's no excuse for not having a ridiculous, scrambled, jumbled up 25-character password with 12 different character sets in it because the application doesn't care. It's just going to pass it over the wire anyway. Nobody really has to remember it, and it's going to be written down no matter what because web apps write down their passwords inside of their files unless you're using the SQL Server integration. So it's not really that hard to remediate that issue, but again, the actual implementation of it in real life can be difficult if you have a bunch of legacy applications already.
Is there an easy way of changing those if you have to across the enterprise, if there were some regulatory requirements or something that says passwords kind of?
There's not an easy way to do it. The easiest way I found, if say you have some, I don't know, you got some legacy app that's under some kind of compliance, and they tell you either get rid of the app or fix it. Well, obviously you'll want to look at trying to buy something else or make something else or build something else. But let's just say that you just can't, you have to fix the application, there's no other choice. The easiest way I found is to just go into the application and find the queries, copy them and paste them into a procedure, because the syntax is going to, the query is the query. It doesn't matter if it's running in the store procedure or if it's running in the application. But you may have to change, if you use any extensions of SQL that are not ANSI 95 compliant, you may have to go through and change those. Now, if you're changing from like Oracle to SQL Server, and you're taking, say, queries in Oracle and putting them in SQL Server or vice versa, there are actually tools by each company, respectively, that'll convert them to the other format. So that's a little easier. But if you're, say, taking a query out of Cold Fusion and sticking it into SQL Server procedure, it's probably going to be a lot of cutting and pasting. By far the easiest way, and I don't even think this can really be argued economically speaking, the easiest way is to build it right in the first place. It's definitely the cheapest. All right, so we covered pretty much all those areas. Capturing passwords, I'm going to hold off till the end. If we have time, we'll do it in this round, but we're probably going to catch that in the advanced afterwards. What we can do is, one of the ways we can get passwords is we can set up our own fake SQL server listening on the network and just wait for somebody to connect to it. You could combine that obviously with social engineering and send out emails saying, I'm having all this trouble with the SQL server. It's at IP 1234, and of course it's really your fake server running at 1234, just waiting for them to connect with that type. The reason that works a lot of the times, unfortunately, is that sometimes DBAs have a bad habit of using the same SA account on a bunch of different SQL servers. So it's the same password. So they know that no matter which one they go to, they just type in whatever the password is. If you get a hold of one of those accounts, it's almost like you've cracked like a domain controller or something, because now you've got access to every SQL server in the environment. Sad but true. So post-exploitation, in other words, after we've already gotten in, there's some Metasploit commands that can make your life as an auditor a little bit easier. So I thought I would show those. And one of them I like is the enum. So we're going to switch to using that. So we're going to set G, the password. I have security password there. I think that's currently the most popular one in the world. It's a good company. Set gr host. The reason I have to set gr is because before it was our host with an S, not our host. Okay, notice the our port. Careful on this. It defaults in the tool to 1433, which is like the default for SQL Server 2005. But I see the SQL Server 2008 Express starts on 1031. We saw that earlier in our scans. We just saved that information. Show options. So we've got our password and our IP and our correct port. Our username defaults to SA in this tool. And it has options for using Windows authentication, but we're using a SQL Server local account. So we'll hit run. And it does like 30 minutes of work for you and pulls out all this information. It's just using the same tables we would use if we went in there manually, but this is a whole lot easier. Still a good idea to know exactly where this information came from. It's all in the sysviews, but once you understand how the tool works, use the tool. So here's all the logins, for example. And then of course, we would go and try to crack those passwords as well. All right, so that's a nice tool to have. We can run Microsoft XP command shell commands with this ms SQL_exe. So what the command shell lets you do is it lets you run Windows operating system command shell commands through the SQL server. So you don't actually need to break into Windows itself. You can use the SQL server credentials to log into SQL server, and if it has enough privileges on Windows, which unfortunately they usually are administrators or systems, even better, right?
Yeah.
You can just add an administrator account for yourself and then go log into Windows directly. If RDP is disabled, you can turn it on in the registry and then use RDP to connect. Okay. So listing databases, we already used the browser service earlier, so I'm going to skip that one. We can list tables and columns. We did that with SSMS earlier. Obviously, you want to look at the tables and look at the columns and see if there's anything interesting in there. There's a better way to do that I'm going to talk about in the next hour. And we can dump the hashes for all the logins so that we can try to break those. So before we do that, also know you would want to grab all the logins, which we grabbed a second ago with the enum tool. You want to grab the credentials. These are really interesting. And grab the backup device properties because you'll get the path to where the backups for the database are stored, which could even be another server perhaps. So let's go back to credentials and then I'll go back to the passwords to wrap it up. And the rest we're going to cover next hour. So for the credentials, let's use SSMS. If we go down under the security and then go down under credentials, what these are is their SQL server accounts, essentially locally, that are mapped to an actual Windows account on that Windows host, or perhaps a domain account if it's Active Directory. So once you get in with even with just a simple SQL server ID, you can then go to these credentials and look and see if anybody has stored their Windows IDs in the SQL server. Then once you get these Windows or Active Directory IDs, at that point you can try to figure out what the password is on those credentials. These are pretty handy. This has worked pretty well before in trying to figure out, once you got into the SQL server, it's like trying to figure out, well, how do I get into this Windows host? XP command shell was disabled, didn't have enough privileges to turn it on. It seemed like a dead end. It's like, oh, well, I got this credential. I wonder if there's any chance that has a silly password. And then, a few minutes later, you're in Windows. Oh, for remediation, might be a good idea not to use credentials. So there is something called the SQL Server Agent, which is a tool that'll run jobs and scripts on your behalf much more safely than trying to run them as a human. Okay, so you don't really need those credential accounts usually. They're not usually necessary. They're easier, which is why I guess they're so dangerous because they're so tempting to use, but you don't have to have them. You talk to your DBA about using the agent.
Sure, that's my card gave just a different script.
All right,
Thank you very much.
All right, sorry, I lost track of time. I'm going to go ahead and get started with the second half now. Take care, man. Or second 45 minutes. Okay, so earlier we had talked about how the browser service is able to, you send it a question, how many databases do you have and what are the names and what are the instances and all that, the ports they're running on. And magically you get this message back that tells you the list of the instances and the ports that they're running on. We had Nmap has that ability built into it. We used SQL scan and we used the Metasploit MSSQL ping tool. So what are those things actually doing? Well, we can use the TCP dump tool to take a look at what's going on. So let's see what network card we're using. Okay, it's ETH1. So we're going to do a TCP dump on interface ETH1. And let's take a look at the actual packets. All right, now that's listening. And so let's go back and use auxiliary scanner. Oh, I hit capitals. Sorry. MSSQL ping. Show options. Okay, so everything is still set up. Run that. Okay, so we see there was a UDP sent. Oh, that's actually it. I don't think we captured everything we were looking for there. Let's see here. All right, let's see if I got TCP dump set up wrong. Now I can't even kill it. Oh, there it goes. Oh, that was the packet. All right. Try a different one, too. Weird. So like, I don't know why it's having a hard time doing the capture, but it sent a UDP packet of length 1, and it sent it to port UDP port 1434, which is the MSSQL-M port. And that 1 byte, if you will, was just the binary number 2. So that's actually all that's in these requests from the browser service. So I'm going to try it in Wireshark. Maybe we can see it a little bit better. There's ETH1, start. Oops. Okay. Here's UDP packets. So the source here is us talking to the server. And if you look very carefully at the very last number there, you can see it's 2 being sent. Okay, now the Windows boxes are getting annoyingly noisy. Let's go look at the reply. Bring it up to where you can see it. So we sent the hex number 2 in a UDP to 1434, and this is what came back from the SQL server. So you can see that's the information that Metasploit is parsing onto the screen. It really is that simple. You send it to, it gives you a big list of stuff on the box. Actually. All right, so that's how the tools work. They send a 02, and the browser service, not SQL server, but the browser service itself gives back the answer. Okay, so for the OSQL, we'll just try that on this local Windows box. So SSMS is what a lot of people will use, but this OSQL tool is pretty handy as well. Let's see. Okay, so the way it works is osql or osql.exe. When you install the client tools, in other words, when you install SSMS, this tool will get installed with it. Dash capital U is your username, S, capital S I should say, is your server / instance. So it's important to have that slash there and then say which instance you're connecting to, which is the process. Because when you pass the instance, that's how SQL Server knows which port you want to connect to. And then dash capital P is your password. So we're connected and we're at an interactive prompt. So at this point, you can basically run all your different queries or whatever. And then when you want to actually run the command, you need to type in go and hit enter. So this tool here can run any query that SSMS can run, but obviously since it's command line, you can put it in a batch file, you can script it, you can automate it, you could PowerShell it, you can do all those things to it since it's an interactive tool. If you get out of interactive mode, and I think it's the dash lowercase q, you can pass it a query interactively. Let's see if I can copy this. Oh, you know what? I don't even think you need to go. Okay, let's see. Maybe it's uppercase Q. Yeah. Yeah, I think you're right. I think it really is that simple. I think if you're in SQL Server, it's single quote, but if you're in the command line, it's double quotes. Yes, thank you.
That'll be the $25 gift card.
Yeah. I actually even said earlier, be careful to use the single quote because if you try to use the double quote, it's going to give you this weird error. But it's the exact opposite on the command line. So anyway, we ran the exact same query, obviously, because I cut and pasted it, and it gave the same results, of course. So, all right. So that is OSQL. We talked about SQL injection already. Okay. Yeah, on the capturing passwords, this one's interesting, just couldn't get to it last hour, but basically, I don't know why I went looking for this. It's like one day I needed it, and then I almost assumed, I was like, you know what, I bet Metasploit probably already has it in there, because it's got all those like DNS servers and those web servers and stuff. Like, why not? It probably has SQL Server too. And sure enough, I went in there, and it was already set up. So it's like use auxiliary, yeah, I think it's server, capture MSSQL. Okay, show options. So I think the main ones to watch out for is there's these files that you can have the credentials automatically dumped into the right format for the tool that you're going to try to use to crack the passwords. And it has the challenge response set up that it can use with the Windows authentication. I guess that's the NTLM authentication, I should say. So it's the challenge part. All right, and then the server port, that you have to be careful again, because if your default port is like 1031, you would have to change that or whatever. And then it's got options for SSL. So I'm not actually going to pick any options. If you leave the host at zeros, it just listens on all the cards. So let's just leave it. Okay, so we're going to run that. The IP of this Linux box is 102. So let's go back to Windows. At least I think it is. And let's go over here and say Object Explorer, Connect, Database Engine, 192.168.56.102. Let's use SQL Server Authentication. SA, password. Oh, I remember, yeah, I mentioned it earlier. I suspected that a team was using the same exact password across multiple servers. Okay, login failed. That makes sense because there's nothing there to log into. But if we go back to Metasploit, it was listening. I even typed in password wrong. But it was listening, and it did capture what I had typed in. So it's as simple as that. That makes a lot of sense, right?
So, did you get them to give up their local SA account?
Maybe. Maybe not. So, I don't know. That does work a scary amount of the time. If you have some mechanism to get them to use the IP that you're at. So whether you use like a header cap to poison the connection, or you somehow poison DNS, or you pick a DNS name that is like teeny tiny amount off from the real name, hoping for someone to type it in, wrong or whatever, or use Sausage Engineering Toolkit or social engineering in general to, basically trick somebody into connecting over there. And it could be something as simple as an email, like I said, of please help, this server seems to be offline. Which might be a good way to put it, because if they try to log in and they get that can't log in error message, then that doesn't seem as bad if they know for a fact they're typing in the right password, or what they think is the right password. Okay. XP command shell. So this is a really nice tool to have once you have the credentials. This takes advantage of the XP command shell system store procedure in SQL Server. You do need to have a pretty high-level account in order to be able to use XP command shell, and it's disabled by default in the newer SQL servers. But this script will attempt to go and make the registry change to enable it. It's like show advanced, and then one, and then there's another command of something else, and it turns on the XP command shell. So if XP command shell has been enabled for convenience by the DBA, it may just be as simple as running the tool. If the XP command shell has been disabled, if you have high enough privileges, you can just get it enabled. So, all right, let's do show options. All right, let's do set command is command.exe. As it applies, you could use other shells like PowerShell or whatever. You don't necessarily have to use the Windows interactive shell. But in this case, we're just going to stick with the interactive shell. 102 is us, right? Scapy's laughing at me. ETH1. I don't even think you have to type in this S0 anymore. I think it's automatic now, or default in TCP though. Let's see. Maybe we're not 102. Maybe that's the problem. Nah, surely we are. Yep, 86.102. Oh, there it is. It is took us some time. Okay, so basically, we sent the command. This is complicated. We sent the command to SQL Server to the XP command shell system store procedure. The system store procedure took in as the argument command.exe/c ping 102, ping back to us, and then it did, the Windows thing, it did 4 pings, and you can tell it's us not just because of the IP, but you can see the time to load is 64, so it indicates it's a Linux or Linux-like environment. And then it just got done and executed the command and stopped. So over here in our TCP dump, we should have been able to capture that. It might be in that mess somewhere. But anyway, you're basically able to run operating system commands through the SQL Server, even though the account that we're using is not a Windows account. It's an SQL Server account. So the SQL Server account is running as the SQL Server service. Whatever authority the SQL Server service has is the power that we have in the Windows box, not the account that we log into SQL Server with. Does that make sense? So that's pretty powerful stuff, because even if you don't have a login to the Windows box, you could just change the command to, use the net.exe shell and then add a user to Windows that has a place them in the local administrators group, and then just log directly into Windows. Enable RDP, enable telnet, the whole 9 yards. That's assuming that the SQL Server has the authority to do all that. And typically, they have quite a bit of authority. They're running it as like a network service account. So if we go back over to Windows, go to Services, and then check on that service, and it's SQL Server. Okay, so log on as is local system. It's a pretty powerful service. Okay, we looked at listing tables and columns once you actually get into the server earlier. We were just talking about using SSMS to browse around with the GUI. Obviously, it's an easy way to do it, but it's not very efficient. If you have a big database or even a whole bunch of databases in the server and you got to go through all the tables and all the databases, that's not a good way to do it. Fortunately, there's that metadata database we talked about, the MSDB, and it has a schema. I can't remember if it's MSDB or the master. I always get them confused. But one or the other has the information schema inside of that metadatabase. And the information schema contains a bunch of views, like tables is one of the views, and columns is one of the views that contains all the information about the tables and columns in all the different databases. So you don't really need to go to the databases at all to look around. You can just use the information schema. When we go back over to our terminal here, let's run a different command. So let's say select all from information schema. Oh, that's nice. Oops. That tables, that's pretty cool. I haven't used that little call it intelligence or whatever before. Okay, execute that. All right. So you see all the tables from this particular catalog is all the tables in master. Now we're not really that interested right now in the tables in there. Let's go down to the brokerage database and say new query. Whoops, it's a new database. Let's not do that. All right, brokerage, new query. Select all and run. Okay, so it'll bring up the catalog, the database, the schema, and the table name, and then what kind of table it is. Different table, there can be different kinds of tables, so I guess be aware of that, but base table is just a normal user table created by the user. All right. Now if you go to the columns view, which is a little more interesting, because it not only has the table names but the column names, but you can still get the table name out. So you can say select the table name and the column name from the information schema.columns. All right, fair enough. But typically the way I'll run it is I'll say like where the column name, and then just say it's like something. So in here, put all your keywords for your audit. So whatever they tell you. So like PCI would be like cards or credit or debit or payment or whatever, right? And SOX would be something, and HIPAA would be whatever, socials or whatever, right? So you say like, looks like card. And you'll just get back a list of the columns that matched your wildcard, and you can chain those together and say, or like, or column name, like, and say like SSN, or whatever your keywords is that you're matching on. Okay. And if you want to get really clever, you could actually have an SQL Server table already built, even on another server, that has a list of all your keywords in it, and then you could simply join columns to your table on column name is equal to the keyword in your table, and then you wouldn't even need a where clause because a join is just as good. So then, of course, you can do all of this like we already saw. You can do it from the command line using the osql. So now we can start to put all these tools and techniques together into something that's scriptable. So information schema is flat out awesome. Matter of fact, if you're looking at like SQL injections that have already happened, like in some kind of a trace file, or you had some kind of IPS or whatever log, you'll see a lot of times those information schema queries coming across first, because in an SQL injection attack, unless the site has a blatant error message that displays the error onto the screen containing the table name, the attacker doesn't really know what the name of the tables in your database are. And they're not going to sit there and guess all day. You can, especially tools like SQL Map has the brute force option where it'll guess the table and the column names. But if you can hit the information schema, you don't need to guess. You can just print them out. So, remediation. Why in the world would you let your application have access to the information schema? So if you set up the application like we talked about earlier, where the only possible right that it has is execute on that one particular schema that we built just for it to dump all of the routines for the application into, it's not going to have access to information schema anyway, and this won't work. But of course, if you had done that in the first place, the SQL injection would likely not work anyway. So while it is possible to accidentally or purposely make a stored procedure or a UDF vulnerable to SQL injection, it is possible to make that mistake. It takes effort, because by default, stored procedures are not vulnerable to SQL injection. Queries that are put inside the application, on the other hand, generally are usually vulnerable by default, and it takes effort to make them safe. So you see the problem is one way starts out safe and then can become dangerous accidentally. The other way starts out dangerous and takes effort, money, time to make safe. That's especially true in PHP, Cold Fusion, things like that don't tightly integrate to any particular database. Which is the great thing about like PHP is it's not sold out to some particular database brand. You can use it with just about anything. But the problem can also be that you're writing raw queries that are sort of like database agnostic, so they're kind of generic queries too. And you're running these raw commands. And if somebody can add a little bit of extra stuff to your query and get it sent across the wire, you got SQL injection.
So stored procedures are generally safe?
Generally safe. You can make them.
I heard the opposite. That's why I was confused.
No,
Someone told me that, if you can, avoid using stored procedures, because if they can get in and get access to the procedures, then
that's
issues.
That's garbage. That's just garbage. Now, when you take the routines, I say routine, which can be a procedure or a UDF, user defined function. Okay, both are equally valid.
Right.
When you put them inside of the isolated schema or the package, and you only give execute on the schema or package, it doesn't matter if you're talking about Oracle or SQL Server. The execute permission does not give you rights to read the source code. It doesn't give you rights to alter it, change it. It doesn't give you rights to use information schema or even get to the very tables that the procedure itself is going to get to on your behalf.
It's compiled.
Yeah, it's compiled.
Yeah, thank you.
It's binary, or I don't know, interpreted code or whatever you want to call it. So, I guess, I don't even know where they were coming from. It's just flat out bad information. But you can make them dangerous by doing stuff like building the SQL statement inside of the procedure, building it dynamically at runtime. Does that make sense? So, now you don't need to do that.
Parameter and make a bad query.
You don't need to do that to do dynamic queries, but you can accidentally do that because you don't know any better. Maybe there's a learning gap between the developer, But
There's a knowledge gap, but not with our boss.
Yeah. So if the developer needs to run a dynamic query inside of the store procedure, well, it doesn't matter. Again, I'm gonna keep going back to this. The query is the query. It doesn't matter where you run it. Okay, so the developers have got to kind of get past that idea that the query in Cold Fusion is somehow different than the query in the store procedure. They're fundamentally the same query. Now there may be some non-ANSI extensions that are added on, especially between database brands, because I always get this backwards, but I think like SQL Server has an extension called Substring, and Oracle has an extension called SUBST, which does the exact same thing, and MySQL has SUBST, I think, as well. And so those are extensions that are different between them, but fundamentally it's still the same query. So it doesn't matter where it's located. If you want to audit your store procedures to figure out if they might possibly be dangerous, what you do is you go in with an account that's powerful enough to read the source code, and then you run query against the information schema, searching the source code, looking for keywords like SP, execute SQL, exec in Oracle, execute immediate in Oracle. I don't know, I got a list of keywords back at the office, but anyway, but that's how you would kind of audit those store procedures to say, is there any store procedures that are kind of suspicious that might accidentally be vulnerable, even though they're store procedures.
Cool.
All right, so earlier we had talked about breaking the passwords and all that kind of stuff. Might try to do that here in a minute. Might try harder. I don't know. We'll see. So one of the things I wanted to look at real quick though was that we didn't look at earlier. We talked about the credentials, the backup devices. I mentioned them in passing. Take a closer look real quick. So obviously I'm not going to go into any kind of details about different things found for my customer or whatever, but just as a general rule, I'll give you some high-level principles that you want to watch out for and kind of audit at your own company. When you set up link servers or when you set up backup devices, if someone gets in and is able to access that information, they're going to find out about other parts of your network. So you want to kind of limit that ability to the SAs, the DBAs, I guess I really should say. Okay. So the link servers, I don't have any, this is a local machine, I don't even have a network connection, but a link server is where basically you set up the connections to say like an Oracle box, for example, or a MySQL server somewhere else on the network. And what that allows you to do is it allows you to actually build your web apps even better, because what you can do is you can have, say, like SQL Server is your main database for your application. So what you can do is you can say, okay, every last one of my interactions with my databases is going to go through this SQL server, through the routines that we placed inside of the isolated schema. And then those routines might turn around and go query some other database on the network, bring that information back, collate it with the information from the local SQL server, perhaps, and then give the information back to the web application. It's actually a pretty good design because it puts the data processing where it ought to be on the databases, and it also allows you to abstract away your data network from the application. So from the application's point of view, there's this magical store procedure that if I call into it, all this data comes back. And it doesn't really know that the data is coming from, like, say, HR over there with their Oracle system, and the factory floor with their SAP system. it has no idea that all that's going on. There's all these providers, drivers, in SQL Server natively that connect to like Oracle and stuff like that. So it knows how to talk shop with those other brands. And of course you can add drivers and stuff too. Okay, so you set up a link server and then you can run a query against that server from inside your local queries. But these backup devices, this came in handy one time because there was this one vendor product I was testing that was under consideration. And the way it worked is you buy the vendor product and they give you the website, the web server, the database. The database server is kind of almost like an appliance you buy, and it's already put together, and it's plug and play. You just hit it, connect to your network, and boom, you're off and running. And so when the application account that was included with the product, it was a stripped down account, but it still had too many privileges. It had access to the tables and the views. So if you could break the application, you could log into SQL Server. It was an SQL Server in this case. And you could get in and you can get an information schema and all the tables and the views. But another thing that was kind of funny is I could get to the server objects. And I got to the backup devices. I got into the backup devices and figured out where the backups were. I couldn't get into the a lot of the information in the other databases because the application account didn't have access. But when they backed up everything, they backed up all the databases on the whole entire SQL server to the same place. Okay, it's just kind of like a job that ran. So ended up getting in through a Windows share on the backups, got the NDB files were not encrypted, and was able to get the other databases. So lesson learned is you got to guard the backup devices too, because you got to kind of assume that if this server gets rolled, they're going to at least know where the backups are. So you got to have the backup location locked down so people can't get into it. In other words, knowing where the backup device is located shouldn't be sufficient to actually get the backups. It seems obvious. You would think there would be some kind of authentication on the backup system, but if it has a flaw like the Windows share is accidentally world readable or something like that, then they're going to be able to copy the MDB files. MDB files are the database data files in SQL Server.
They don't have to use a backup account to.
Well, the MDB files are raw files, so you need a backup account to
get on the backup server or
to
run it.
To run the backup jobs and things like that. You don't necessarily have to be a backup account, like you could be an administrator, for example, but you need to have the authority to do backups, yes. But you don't. But once you make the backup, when the backup writes it out to the hard drive, it's just a Windows file. It's just it's a text.
You can attach it to a different server and
it's just a text file.
Establish accounts and grant rights and get everything in the table. Might have everything in there.
Yeah, and it comes in handy. I mean,
you'll know all your accounts because they'll orphan. If you have any SQL accounts, you'll know the original source.
Yeah, it's not necessarily a bad thing or whatever. It's just you got to treat the backup the same way you treat the production environment. That's all I'm saying.
Or more so, make sure it's protected.
Yeah, that's all.
They get that, they got it.
That's all I'm saying.
And more.
It's the same thing as someone knocking over your database if they get a hold of your MDB files or your Oracle backups or whatever. Or third-party backups. There's other software you don't have to use Microsoft or Oracle to back up your databases. You could use Legato or one of these other third-party services. So another thing to watch out for is those MDB files can contain credentials in them, not just the data too. Just like the SQL Server tables can have credentials in them, and the DTSX files and things like that. All right, I think we got through everything. Yeah. All right, cool. I'm gonna take one more shot at those passwords. I just can't let that go. Because it worked so well last night when I was half asleep, and then today when I'm fully awake, it doesn't work at all. So maybe the key is, so I need to wait till about 2:30 when I'm half asleep. Try again. All right, so it was an MSDB. It's a view. It's in the sys schema. No, it might even be still open somewhere. So we can close these. Oh, maybe not. All right, table's called sys logins. Okay. Oh yeah, by the way, some bonus material. Use auxiliary, scanner. I'm sorry, auxiliary admin. You have a question, bro? Oh, okay. Ah, there we go. Scanner, I don't know, it's under scanner, so, okay. Show options, password 1, run. Okay, so the MS SQL hash dump tool in Metasploit automates going into the sys logins and grabbing the columns and dumping it all out for you. A couple caveats that I'll tell you about that I learned the hard way. When you go to try to crack these, you see how those letters are lowercased? You have to uppercase them before you try to crack them with the version of John that I currently have. And whether that gets kind of fixed in the future in either one tool or, I mean, it's not really an error or a bug. It's just one tool outputs it one way and the other tool expects it another way. You just have to account for it. Took me forever to figure that out. It's like 15 minutes. I'm like, I don't understand. When I run the example, it runs fine. And then it dawned on me, oh, that's lowercase. Maybe it matters. Sure enough. You can use the DD tool, conv equals ucase to uppercase everything. However, these accounts still need to be in the case that they came out of the SQL server in. So if you just blindly uppercase everything, it doesn't work again. So you have to re-lowercase back down these. And don't forget that some of the tools, the cracker tools for password cracking, require that 0x to start the hashes, and in order for it to know that what format it's in, that it's in the hex dump of a hash format, if that makes sense. Okay, so yeah, now we get all kinds of traffic, right? So, all right, let's close that. Close that. Go back to Windows. There it is. Okay, and of course you can delete all the stuff that you don't want. Let's see. Oh, spaces don't matter. Sorry, I did it again. I did SQL logins, didn't I? I meant sys logins. I wonder if these would work. No, let's try it. Yep. Okay. Don't need that column. Like if you arrow over. Alright. E. Okay, it already has the little 0 by in front of it, so I'm just going to go with this. Stretch that down. Use that magical expand out thing feature. I know it's something really easy, but I'm just not sure what it is. Just for fun. I mean, they look exactly the same, don't they?
Well, about the second line.
Yeah, these are like the built-in accounts. I mean, we can delete them. But, you know, it seems like everything lines up and stuff. But it
They
just,
are exactly the same.
Yeah, I know. It's like, just couldn't get it to work. I'm not really sure why. I'm sure it's something obvious too. Whoops. We're in the right directory. Well, let me just double check the formats real quick. It's like, oh, where'd it go? See, there's one that's MS-SQL, and there's this other one that's MS-SQL5, and then it can do the MySQL too, of course. And I know from experience, this Oracle one works awesome. Like, super fast. Okay. So if you can get into an Oracle 11G with backwards compatibility or 10G or newer and grab the user's $ table, same deal. MS SQL 05, I think it's correct. It just doesn't work. I don't know. Now it seems to be working. Go figure. It looked exactly the same though, didn't you think? It's like, I have no idea what little invisible character I had in that first file.
I made a sacrifice to the demo gods for you between breaks.
Oh, thank you. I appreciate that. So you slayed a Diet Mountain Dew in my arm. So, so okay. So remaining 2 password hashes. So let's just go ahead and kill that. And then the magic word is, other than please, is show. Okay. Okay, so we got 4 out of the 6. Anybody knows how long it took it to get the 4 that were relatively easy to break? It was like, I mean, it wasn't a second, right? It was like some number of microseconds or something. That password might look kind of hard, but it's just support backwards. And John will try those kind of easy things right away before it reverts back to doing actual brute force. Username equals username. I think we mentioned that earlier. Dictionary words with a number on the end. That one's like a cat. So cat name, stuff like that is. Pet names are really easy. So I don't know. Maybe I need to revise my script to hit the SQL logins table and just go with the password hash in there, because apparently it's already in the right format without us having to fiddle with it, as opposed to using. But I did use the login properties built-in function, system function last night to grab from the sys logins table, and it did work just fine. So I don't know. Do you have a question, Adrian? Or?
I was thinking about, I haven't looked into John and Hashcat in a few years. Do you know if they've added some optimizations for John yet for doing using your video card, or if Hashcat supports?
Hashcat supports the video cards.
I know,
but I don't recall if it supports SQL Server 05 format or not. And I don't know. You know what? I have to look it up.
Yeah, when you had a list of different things you could crack with John, there was a couple things that list that weren't there when I looked at it last. Like
it wasn't in Hashcat?
Well, not necessarily in Hashcat. Well, not in Hashcat either, but not in John a few years back. He was like Cache version 2.
Well, I guess full disclosure, I'm using John with a jumbo patch or whatever, so I've got some extras.
Is that built into Backtrack, or do you have to add it?
Backtrack 5R3 with the latest updates gets, I think, John 171 with the jumbo. So it's kind of auto-magically ready to rock when you out of the box.
Lazy bastard Linux, gotcha.
Yeah. I use Backtrack because it is the easiest.
Yeah, that's.
I mean, I already don't have time to get all the work done as it is, so I'm not going to make it any harder.
Back in the day, it didn't have even MS Cache built in. You had to add it in yourself, and it's a lot of steps. It's a pain in the butt, and so I'm glad they put it all there.
Oh yeah, Backtrack and Metasploit have they've always been very, very quick to advance, but just like in the last couple of years, both of them have just really accelerated their pace. I mean, they both expanded so quickly. So I think just recently, even like the Metasploit, the ability to pull up information from the database and stuff like that got radically faster, like 1,000 times faster. You can do searches now really quickly with the index searching and all that. So yeah, much more usable. when you're in a hurry. The Oracle and the Oracle here, that's the Oracle 10G and the Oracle 11 with 10G compatibility mode, and Oracle 11 is obviously 11G. And MS SQL 5 is obviously 2005 and 2008 in when you're using the default local accounts. And then the MS SQL, I'm trying to think I think that's when the 2007, I might be wrong on that. I think that's SQL 2000 format. So 2007, 2000 format. So, alrighty. Well, other than Scapey making an idiot of me, it's just not hard to do. Everything else, I think we got done. So, I have no idea why that didn't work. I'll have to play with that again. But if you want to try it at home, it's basically just, you know, create a IP packet, unless I'm wrong about that, put in the IP, and then add onto that your UDP, not TCP, UDP, and set your destination port to 1434, and then you got to send a hex 02, so that's like load equals 02. And then maybe it'll work for you. I don't know.
What happens if you go ahead and change the source port to something other than 53? Assuming you're not running a web service on this.
Like 10,000 or something.
Oh, okay.
Huh. It is different. Maybe that worked.
What was the exact DNS wrong value?
I don't know. Yeah, let's try something real quick. It's like, let's see, TCP.
Name server error.
DNS don't mean a whole lot to me either on the DNS side. I was wondering if this has a DNS server running on it, or
yeah, I don't know. Maybe
like you were doing some kind of poisoning in an earlier demo, and
might be Adrian for the win here.
it happens very occasionally. Really, really, I should say.
Let me try something else. Let's try.
English, no, I'm good at.
For some reason I have no idea how to open up Wireshark without opening a terminal first. There's got to be a shortcut somewhere in one of those menus.
It's hidden in there.
Is it? It's one of the, yeah, you kind of have to scroll down to get it, or open up a bunch of the menus.
I'm not sure if it's in information gathering or if it's underneath.
Yeah, network something. I could find it. It's just
Easier to bring up a command.
Yeah, I get irritated easily. Let's see. It says got one answer, but oh, wait a minute.
It's right there.
So source was 102, right?
It sent it back, didn't
Let's see. Stop. Okay, there we go.
it? Right there.
Oh,
There's the information.
yeah. Oh, thanks, Adrian. I think you solved the case of the missing Scapey.
I have no idea why the 53 wasn't working either.
Turns out it was Mr. Jones just wearing a scary mask all along. There it is. So here is the response from the service from our Scapey packet that we sent. And it's got all the information in it. So it's just, I mean, it's not necessarily useful to build the packet manually with Scapey other than academic. It's just that if you're going to use the tools anyway, it's usually a good idea to figure out how they work and then try to make sure you understand what they're doing. And if you can recreate it, then obviously you probably understand it pretty well, despite the fact I couldn't get it to work for an hour. But it turns out that having the source port set to 53 is a problem for some reason. Maybe the SQL Server browser service wants to see a high port, because something I did notice when I was messing around with it before is if you try to log in anyway, which is not the browser service, that's logging into the process, SQL Server process. I noticed that the client side SSMS would start the port at like, I don't know, it was like 10,300 or something. And every time you would log in, it would use the next highest port, and just keep incrementing it by one. So maybe there's something about the service that wants that high port. That's why I kind of picked 10,000 when you said that. Just thinking back how I saw that client acting when it was picking its own client side port. Let's see. We could try changing it to 1,000 and see if that has a negative impact. Nope. Let's try changing it back to 53.
Yeah, change it back to 53.
That has a negative impact, so 53 is bad. Let's try 54. Apparently there's something really magical between my two virtual machines about this 53 source port. I don't know if it's me or if y'all can recreate that same result when you try.
I think they're doing a DNS query.
But
I don't know if it's you're sending it or if the receiving box is receiving it saying, hey, I'm seeing this from port 53. Really shouldn't matter.
unfortunate mistyping there. Alright, let's see, Windows box. Kill this thing. Okay. So if you want to set up your own virtual machine at home, obviously if you have a Windows virtual machine running, you can download a copy of Microsoft SQL Server 2008 Express Edition. That's what we were using today. We were using SQL Server Management Studio, also free. Be careful that you get SQL Server Management Studio 2008 if you download SQL Express 2008. You can, they're backwards compatible, like you can use SSMS 2008 with SQL Server 2005, but you can't do the reverse. Okay, so you should be able to get everything running. The rest of everything else I used is all 100% free. Like, well, even SQL Server Express is free. It's just a limited version of the real SQL Server Business Edition. So you can recreate everything. All right, except for the Windows license I have for the virtual machine. It's the only thing that wasn't free. All right, thanks for recording everything, Adrian. Appreciate it. As always.